Good morning, everybody. I'm Paul Taylor over here at Jamboree Valley Farm, and we're learning how to sustainably manage agriculture, whether it's city farms, community gardens, or broadacre agriculture. What we've done is we've combined soil microbiology, permaculture, traditional old-fashioned farming techniques, and a lot of experience to develop the biovital system. Biovital system is a type of bioorganics because it's bioorganics, and it's bioorganics because we combine the complex sciences of plant nutrition and soil microbiology with organic principles. And what this does is it brings organic agriculture back into the form that I believe it should always be in, as a low input agriculture, so we can be profitable again and we can grow food for local communities for very low cost. It's the biology in the soil that reduces the input cost. So we've been discussing the three elements of the system. One is vital compost. The point of difference in biovital compost is that it has all the benefits of any good compost, but the additional point of difference is it has a massive diversity of beneficial plant and soil microorganisms. And we're talking about tens of thousands of species. More than 30% of the finished compost is living organisms, so it's an inoculant. It's an inoculum compost. Okay. Now we take small amounts of inoculum compost and we wash the microbes out of the solution in what's called a compost tea brewer. Here we call it probiotic. It's plant and soil probiotic. And in this process, we grow hundreds of thousands of organisms into thousands of millions, quite literally, over a 24-hour period. Okay? So then we have a liquid solution that we can apply to our productive crops in our degraded soil, to microbially restructure soil, to build fertility, to accelerate the humus forming process, to sequester soil carbon from the liquid carbon path of the photosynthetic process of plants, combined with the mutualistic process of mycorrhizal fungi. And thirdly, we have biofertilizers and associated products. Okay. Today we'll make something called fossicle, which is soluble phosphorus, soluble silica, and soluble calcium. Okay. That's one of the products we're going to make. And we're also going to make the biofertilizer. Okay. So we'll do those two things today. And then we're setting up a dozen samples to look at under the microscope, so you can see what living water looks like as soil probiotic. You'll witness hundreds of thousands of species and billions of microorganisms interacting under the microscope. It's very cold conditions. This is a very cold tea. It's brewed at about 10 degrees Celsius, which is very cold. And we nickname this iced tea, because it's under cold conditions. The beauty of it is that these are the organisms that are active in cold conditions. They will warm your soils, and they will deliver foods to your winter active pastures and your winter active crops. Okay. So that makes it a very valuable application. When we apply probiotic, we're applying it with biofertilizer, and biofertilizer feeds the plants and feeds the organisms. And when it feeds the organisms, it holds the nutrients in the soil. We, as a collective of organisms in high diversity, that's referred to as the soil food web, and they're responsible for what's commonly called nutrient cycling, which is the delivery of non-plant available nutrients, converting it into plant available nutrients, and then delivering it to your plants. Okay. So it's a very balanced natural system of bioorganics. It's by that combination that we're reducing our input costs, we're reducing our labor, and we're improving soil fertility as we improve our production. So we have to change agriculture around to a management system that ensures that we're building soil fertility as natural capital, and then our production is the interest gained on that natural capital. Who went down to the compost pile today? We made a couple of days ago. And what's the temperature?
Just under 50.
Okay. And what day is today?
2.5 at the moment.
Okay, so we might be lucky and hit 55 degrees in 3 days. Okay. And 55 degrees on the third day shows that it's a very good combination of materials. We don't have to amend it when we first turn the compost stack. Okay. And we can be very comfortable that we're doing the right thing. I'd like to emphasize that the temperature is not an indicator unless the moisture level is correct, and we experienced that on day 2. We had a drop in compost temperature because the compost stack wasn't wet enough. As soon as we adjusted and corrected the moisture level, it only took 2 or 3 hours for the temperature to start accelerating again. Yeah.
With the temperature, when you get to your 55 after 3 days, but you don't turn it to day 10 or 12,
Yeah.
does it stay at 55 or near day 9 and 10, does it start to come off a little bit?
Well, what we're talking about, if I can get you in here, what we're talking about is we'd like it to get to 65 degrees. Okay. And when we get to 65 degrees, that's the maximum opportunity for this group of organisms. They live and are most active between 40 and 70 degrees. So 65 degrees is where it should settle down.
I'll